So we are going to investigate this particular situation today. You're offered a job with a starting annual salary of $50,000 and two options for determining your annual raise. You have to decide you're going to get an annual raise of $3,000 each year. Or you have to select a 5% raise each year. Can I get 2 volunteers? You want to volunteer?
Yeah.
Okay.
Another volunteer.
And Barry. Okay. So I need one person over here at this paper.
Okay.
And there's a box of markers, and one person over here. Yes, sir.
Because that 5% add on to your already 5% that you get.
So each year, I think I understand your question. Like your first year, you'd get 5% of the $50,000. But in your second year, you'd get 5% of what you were making that year.
After that 5%.
Yes. Yes. Okay. So we're going to create a table and a graph to represent this. And we're only going to set up a couple, but I want you guys to pay attention to how we're doing this, because then I'm going to put you, well, you're going to put yourselves in smaller groups as you continue to investigate this, okay? So, Kayla, I'm going to have you do the table, and Barry, I'm going to have you do the graph, okay? So you need to set up an X and Y axis, and you need to make a 3-column table. 3-column table, because we're going to have number of years, and then we'll have a...
Right on the other part, too?
Huh?
Should I use, like, the whole...
You can use the whole page. That's fine. We need 3 columns. We need 1 column for, what year you're in, and then we need a column for each of these raise options.
3. This is 3, right?
Yep.
Okay.
That'd be fine.
Oh my goodness, okay.
Yep. Okay, so left-hand column, go ahead and label that year. All right. And then in the middle, let's do that annual raise of $3,000.
So, write what?
So you could just write, $3,000 per year.
Okay.
And in the other one, we're going to do the 5%.
The last column?
Yep. All right, so year 0, grab a color, and then Barry, whatever color she chooses, you're going to need to do this in the same color.
I think
Okay. So in year, at the beginning, so we'll call it year 0.
Okay.
If you select the first option, how much are you going to make that first year?
53,000.
Wait, what?
If you select the first one?
Like your beginning
Oh, 50,000.
50,000. So in year 0,
Oh, yeah. 50,
so down year column, put a 0. You're going to make $50,000.
Right, keep across
Yep,
for both of them?
for both of them. All right. So over on the graph, this would represent what? If it's year 0.
The starting cost?
Starting amount, yes. So this is our y-intercept. So on the y-axis, we need to have a dot. You're going to need to decide where it goes, and then we're going to need to label it 0, 50,000. All right. At the end of your first year, so we're going to put year 1 now. If you choose this option, how much will you make in that year? 53,000.
For only this one, though, right?
Mm-hmm.
Yeah.
What about for this option?
50. Oh,
I'll just calculate.
I don't
I
know.
think so.
Well, don't we add like 0.5?
Is it times 0.0 or is it
Times 0.05.
just 2,500?
2,500 would be your raise amount.
Yeah.
So how much would you make in that whole year?
52,500.
52,500. Okay, we're going to need 2 dots for this. 1 for each of those different amounts. So on the x-axis, we need to go over 1, and then we've got a dot at 53,000 and a dot at 52,500. All right, we're going to do one more together as a group, and then you guys are going to be put in smaller groups. You're going to make a table and a graph as you continue to explore this out, because we're trying to decide which of these is the better option. Okay? All right, so you've completed 2 full years there. You're up for your employee review. They're very pleased with you. If you chose this option right here, how much are you going to make that next year? 56,000. What about if you chose this option here?
Is it 5% of this or the 5% of this?
5% of
The
this
original
one right here. Nope,
Oh.
5% of this
the new
one.
one?
Good question, yes.
Are we multiplying?
So we have to do it again, right?
Yes. So you're going to multiply 5% to this.
Isn't it 0.?
0.5, yeah.
Yep, 0.05.
It's 26.25.
2625 is what gets added on to your base.
Let's see if I can add right.
So we're going to add 2625 to that.
Oh, it's just, okay. I'm like, wow, this is, no, that's wrong. Is that right? LOL.
Wait.
I'll just rewrite it. I'll just rewrite it.
Okay.
The verb is LOL.
Right.
Wait, where did you get the 55 from?
She's taking 52,500 and adding the 2625 to
I
it.
couldn't do the 125.
Oh. Okay.
Because you're taking that amount, that's the amount more that you're going to make the next year
Okay.
that gets added on to your base. Okay, so we need 2 more points for these. So we need each of these represented at year 2. All right. Good question. Okay. You guys need to get into groups of either 2 or 3. I'm going to give you a large piece of paper. You can use markers, colored pencils, regular pencils, but you need both a graph and a table for these options. We want to determine which is the better choice. Okay?
Okay.
So we've only got the first couple out here, but you want both a graph and a table.
How far down, like,
Go as far as you think you need to go to decide which of these would be the better choice. Okay?
Skip numbers.
You can choose to skip count if you would like. Yes. All right, so find who you're going to work with. We've got the first couple started for you on the table. You want to continue this process.
Oh, yeah.
I'm not gonna be bitter about it.
right, so you're gonna be like,
Do you want to work with these ladies?
Okay. Yeah, okay. What is better? It's 5% because it adds up. If they're getting like $100,000.
So 2 or 3. 2 or 3. Yes, ma'am.
You be squinting your eyes.
Yeah, we can do it before, as long as everybody's participating. All right, someone else you work with? Oh, you want to come over here and join this group? Okay.
I'll write down the ones that already.
You guys are gonna work together.
Oh, they're growing.
Yeah. Christine, are you?
Shut up.
I'm just rewriting your work.
Oh, Alex, Scott, I'm sorry. I misunderstood. You pointed and I didn't hear the rest of it.
Okay.
Okay. We're going to spend about 10 minutes with you guys exploring this. So take it out as far as you think you need to reach a decision about which raise option should be chosen. All right, so I'm curious. We're going to start having a conversation about this. If you're still finishing up your graph in your table, that's okay. When you're done, get it hung up. But I'm curious. Hopefully you guys have been able to get far enough. Which job, or sorry, not which job, which option would you guys take?
The 5 to 5.
I would do the 3,000 because I don't see myself being at a job.
Yeah.
For 10 years. So I would take the 3,000. I'm like, give it to me now. But if I was going to be there for a long time, I'll take the 5.
So I'm curious about that because you used a very specific number that wasn't in anything that we've talked about, and I like it. Yes, you did. You said you would choose the 3,000 option because you don't see yourself staying at a job for 10 years.
Because at 10 years, you make more with the 5% than the less.
At 10 years, you make more with the 5% raise than with the 3,000 per year.
It takes 10 years to do that.
Takes 10 years to get to that point.
Exactly.
So these questions down here, does it matter how long you plan to stay at that job? Yes.
If a couple of years, 3,000.
Yeah. If you think, oh, this is like a 5 to 7 year job,
Yeah.
and then I'm planning on moving out of state, I'm just thinking something less than 10 or 1 to 3 or whatever.
Right.
But yeah, if this is your forever job, you're going to stay there long term and you're locked in to one of these two choices, I agree. 5% would be better for the long haul. So I'm curious. Can we write equations to figure out the salary in T years? And what kinds of functions are they?
What's it called?
So let's talk first about this one, the $3,000. What kind of function is that one? Constant. And so you said linear. This one was linear. And you should have noticed that when you made your graph, although I realize I didn't give you graph paper. But for the most part, you were going up by the same amount each time for every year you went over. How do we write linear equations?
Just you have to write the rate.
The rate
Starting.
What? Oh,
and
it's
the starting amount.
Yeah, the starting.
Yes. Okay, so we have our rate, and that's what we keep adding on each time. So we multiply that, in this case, by the number of years. So how would I write the linear equation for this situation?
Y equals
So B would be 50,000. Oh, wouldn't be.
Is the rate 50,000 or is the rate 3,000?
The rate is 3,000.
The rate is 3,000. So how would I write this now?
Oh, so 3,000 x.
Yes, and I'm going to have to move this because I just realized how close I was to the edge of the slide. Y equals 3,000. Instead of x, we're going to use what? T for time. Plus what?
50,000.
50,000. And what does that 50,000 represent?
The starting cost.
Starting amount, yes.
Starting. I know. I keep saying cost. I think that's always stupid.
And when you go to graph it, that 50,000 goes where on the graph? You said it's the starting amount, so it would be your y-intercept. That's your vertical intercept, your y-intercept. What kind of function is the 5% raise? Exponential. Oh, goodness, and I can't draw a straight line all of a sudden.
Me every day, right? I know what you're. Do you like it? Oh, yeah. She's jealous. It's backwards 3.
That's exactly what it is.
It just looks weird when I'm like.
Exponential functions we write as y equals a times b to the x. B does not mean the y-intercept here. This is just our basic form. In math, we recycle letters all the time. And really, these letters are just stand-ins. What does it mean if we take something to a power? Yeah. This thing, you're going to multiply by itself however many times this is. How many times do we multiply by this number here? Just once. This right here is the y-intercept when we're talking about exponential functions. So when I go to write this equation for the 5% raise, what should I have right after the equal sign?
50,000.
50,000. That's our starting amount, our initial amount. And then we multiply that by whatever the rate is. The rate was 3,000 for the exponential function? 5%, but that's always getting added on, right?
Yes.
5% of what you were making before. So if I'm thinking about this in terms of like percentages, I'm not just going to be making 5%. I'm going to be making 5% more. The way I represent that is by doing it as like 105%. Because I'm going to make all of what I made before plus 5% more.
That makes sense. I would have never known that.
So the way I write that down is 1.05.
Oh, so it's like one, and then it's like a whole, and then the 5.
Yes, I'm going to make
And then that's still.
one whole of what I made before, and then another 5%.
And then the T is still the year, right?
Yep.
The time.
T is still the year for the time. Absolutely. So to finish up here, I want to talk just a little bit about other features that you guys noticed. Domain. What do I mean by domain?
That's the. What is that? The X, like the whole.
That's the X's, that's the input. Domain is all the things that we can take as input. In this situation, what types of numbers can we take as input for T?
Like I'm going to
Whole numbers,
whole. 1, 2, 3.
rational
Yeah,
numbers.
positive.
Interesting. What do you mean by rational numbers?
I know there's like, like rational numbers are like, I think it's like positive whole numbers or something.
So positive whole numbers, those would be our counting numbers. Those would be positive integers. Integers is what we use to say whole numbers.
Okay.
Rational numbers are numbers that can be whole numbers, or it's also numbers that we can write as fractions.
Okay.
So most of our decimals are rational numbers. All of our whole numbers are technically rational numbers too. Can we have negative numbers as input in this situation?
No,
Why not?
because you can't have negative years.
Negative years doesn't make sense. Like, they're not going to pay you for years that you
And then
didn't
they
work
start
there.
taking away your salary. The longer you're going.
So, if we weren't talking in context, would there be that same restriction on input?
No, it would be like all of the numbers.
All real numbers would work if we're just talking about functions, but in this situation, in this context, we have to narrow it down to just the positives. What about the range? What does range mean? The Y's, that's your output. In this case, the range is representing what? Money. Yep, your salary. What kind of values were we getting back for salary? Yeah, positive numbers. Now I'm curious, if we were not talking in context, linear functions, do you only ever get positive numbers as output for linear functions? No, it's possible to get negatives. Not in this context, but with linear functions, those can go into the negative side. What about exponential functions?
So you're asking like if they do the same thing? Or
I want to know if we can ever get a negative output from an exponential function.
In this context.
In this context or in any other.
In this one, I would say no. I don't feel like you can.
Correct. In this one, you cannot get negative output. You're not going to pay them to work there.
Right.
What about in other contexts? Would it be possible to get negative output?
For exponential, yeah, I mean, maybe not because it multiplies and then it multiplies. I don't know.
Well, if I'm writing it like this, right here, if I have a positive number for my input, what kind of output were we seeing? Positive. What about if we put negative numbers in for input? I know, grab a calculator, let's try it. I know negatives don't work in context here, but try it. Put this in your calculator and choose some negative numbers to take to a power. And see what kind of output you get.
Would have been like domain error. I would have. I freaking did it wrong.
You got a positive? You got a positive? What was your input?
I've got a positive.
-1. What did you choose? -5.
-3.
You did
But
-3.
it went down.
The money went down, but did it become negative?
No.
Okay.
Well, not yet. But maybe if we did it like 8 more times.
Try it. Try some larger negatives.
'Cause, like-
Try something crazy like -100.
Crazy. I know crazy.
And that's
Me, negative
I got
1,000.
exactly. I got 0. You got 0. You got the one number that you can put in to. What did you do about -10?
10,000? That yeah, because you did it. It's 50,000, and then it's 105, so it can go into it like all the way.
I know.
Well, we'll do 11. I'll do 11. That'll be negative. No.
Are you guys able to get negative outputs?
No, you don't.
No.
It like just goes back. So does it like
Yeah.
like does it? go back?
So what it's going to do, if I'm looking at a graph, a line would go straight through and down into the negatives. But this, as we get close to that x-axis, it's going to flatten out.
And then it flips back up. Or no?
It does not ever flip back up.
So it just like evens out.
Yeah.
Okay.
Technically, it's getting smaller and smaller each time, but it's getting just a little bit smaller. So one of the ways that I remember a professor explaining this one time, he said, like, if I could, in one step, go half the distance from the back of the room to the door, like just imagining for a second, I can take a step that big. And then my next step, I go half the rest of the distance to the door. And then I go half that distance to the door. Will I ever actually make it out the door? No. Not if I just keep taking steps that are half the distance.
Then you'll get so like.
It's going to get
You're not
closer
even
and
moving.
closer. Like
You're gonna be
I'm
like-
barely going to be moving. I'm going to be moving millimeters.
I'm walking here.
But I'm never actually going to cross that line because I'm always just going half that distance. Gets smaller and smaller and smaller, but never crosses that line.
So we'll never have a negative output for X.
The only way you would have a negative output is if at the end I had like minus something.
Okay.
That's the only way you could end up with a negative output there. All right. You guys have your first homework assignment of this unit on growth and decay. Page 114 has all the same questions, so you've got page 114 for your scratch work and your thoughts. I do ask you to upload some pictures of sketches that you have made, so you can make those sketches on page 114. Please make sure that you hang up your graphs and tables if you haven't done so already, and I will see you guys back here tomorrow.